Go is fast and scalable, but knowing how to store and manage data effectively is what makes a program scalable. Should you use array or slices, or should you use something that is more flexible and has very fast lookup? Or what about the structs and interfaces, which are the backbone of writing a scalable Go code? In this video, we are going beyond the learning syntaxes. We'll be building a in-memory database similar to how Redis works, but without the complexity of client-server model. In this video, we'll cover array versus slices, maps, pointers, and also structs and interfaces. By the end of this video, you'll have an understanding of how how a data is managed in a Go and how to write a scalable code, and also you will have built something real world and practical. So let's get started. Arrays and slices are essential data structure available in Go that is used for storing a collection of values. While both can hold multiple values with the same type, their usage and flexibility differ slightly. For example, arrays is fixed at a time of declaration, while the slices can grow and shrink dynamically. Second is that array is stored in a contiguous memory while slices are backed by an array and dynamically resized. In this section, we'll explore arrays and slices with example to understand their differences, advantages, and the best practices. Let's get started by declaring an array. To declare an array, we go with var number. Now to declare an array, we use a square bracket and then provided by the type of the value that we are going to be storing in this array. Also, we have to provide the size of it. So let's go with 5, and let's start by printing the values first, and let's see what we have in it. So we go with fmt.println and number. Let's save, and we do go run main.go. As you can see, we get values as 0. So the key takeaway here is that the size of an very array is declared when we are declaring the particular array itself. And second, any uninitialized value will be set to the default or the zeroth value. For integer it's 0 and it's false. For boolean, for string it's gonna be just an empty string. Next, let's keep this. Let's initialize our array. To initialize our array, we have to provide again with the square brackets with the size in it, with type, and then we provide with the value like 10, 20, 30, and we can keep the last two empty as we know that we are gonna get 0. Let's run this program and see what we get. We get 10, 20, 30, and double zeros. Now here's the thing, like, why we need to provide this twice? We can just do it once. That's fine. This is what we call an explicit declaration. We can also do like names equals to um, type string. Let's go with 3, um, 3 and type string, and let's provide with the value like Alice, Bob, Dave, XYZ. And we can also do something like let's say primes, and we can go with type int, and we can provide values like 2 3 4 no no 2 3 5 7 9, and to let that to let the Go compiler know that we're only providing the size for this, you have to figure out we can provide just triple dot. This way you don't have to specify how many elements are gonna be there. Sometimes you have to store 10 elements, sometimes it could be 20, but you know there is a fixed size of element that you want it to be there. So you can just use triple dots and it will get the length of it. Now let's print all the values. Fmt dot println as names, and last fmt dot println primes. Let's check their values. If we run, we see that we get 10, 20, 30, and double zeros since we have not specified the last two value for the number. We get names as Alice, Bob, and Dave, which is true, and then we get the primes. Now we can also modify the value. So similar to any other programming language, the arrays here are zero indexed. That means I can do names of third element to change it to be John. Now the thing is, I've put it here 3. As you can see, it's not in the index, it's out of index. But if you do this, you get this error which is index 3 out of bounds. So make sure that you are always under index. So 0, 1, 2, and we are changing Dave to John. Let's run this and see. Yeah, so we get that. But if we are doing something that is out of the bounds, you're definitely gonna get that error which we don't want. Now let's move on to the looping of the arrays. To loop through array, we have two methods. One is the standard, which is, let's move here and we'll add loops here, which would be using for loop. Yeah, there is no other loop except for in this language. We go for initialize it to 0, I less than length. Basically, it's a function that returns the length of an array. We use primes, and then I plus plus to increment the value, or else it's gonna be stuck in a forever loop. Then we do fmt dot println, and we just go with um, primes of I, and let's save and clear this, and let's run. So we get this 2 3 5 7 9, which is through this for loop. Again, Go has something much better that can be used here for looping over such kind of any kind of array or slices. So Go provides with something known as something we can call it as a range keyword, or an operator. So it returns the index and num, or you can just name it as a value for the range, and we can do primes. So it's gonna get the index and value while iterating over the primes array. To store that, let's use fmt dot printf, which is print format. We'll be formatting our string the way we want. So here we will add something like index. It will be percentage %d, a placeholder for decimal, and then value again percentage %d, another placeholder. Then the value for the first placeholder would be an index, and for the second would be value. Now one more thing, since we are using printf, everything is gonna be on the same line, but we want to be seen as line by line, so we can use \n. It's very similar to what we have in most of the languages, so it's very easy to pick up. And if we do it run now, we get index 0 value 2, index 1 value 3, and then all the index and their values. So the best practice is to use range to for the readability and avoiding any indexing that we don't need. At the same time, the range is a Go idiomatic way to iterate over an array. So arrays are of a value type. That means that whatever you do, they are gonna be of the same type. So we can also do something like we can copy the value. So let's just comment this out part, and let's take a look at what do we mean by a value type. So let's create an add one. Let's create it as a value. Let's add it as a 3 integer and give it like 1 2 and 3. Now if I do add 2, which is a new, and we set it to add, so here what happens is that the array 1 is copied to array 2. It doesn't put it as like, if you're in language like JavaScript, you know that if you're setting an array 1 to array 2, if you make a changes to an array 1, let's say like I'm doing array 2 of 2 equals to 100, and just do a println, and we go like add, and just copy and add 2. Let's save, and it should, they both should have their individual values. They should not be having a same value like we have. It happens in JavaScript a lot. So we can do like Let's run main dot go. As you can see, we get 1 2 3. For the array 2 we get 1 2 and 100. So this is an array in GoLang. Now let's talk about slices. Slices are dynamically sized, flexible array-like structure. Unlike arrays, slices can grow and shrink as needed. They are backed by the array itself, but when we go past the limit of that particular array, GoLang creates a new array, copies all the value there, and then adds all the new value that we need. So there are multiple ways that we can create and slice. Let's go by the some simple way. I'll just let's remove this part and then we do it once again. So let's create an array with type of, let's say, 5 int, and let's provide with value 1 2 3 4 5. Right now, to create a slice we can use slice, we can just assign it to, and we can use add with 1 comma 4, 1 colon 4. So 1 colon 4 is gonna do what is gonna do is gonna just create a slice out of an array, starting from the first value till the starting from the first index till the third index. The fourth index is gonna be skipped, similar to many other languages that we have seen with the ranges and stuff. Let's do fmt dot println and let's print slice for now, and let's check the value. Go run main.go, and we get 2 3 and 4, which is our slice. Right, let's clear this. Now this is a way where we are creating a slice from an array. What about if I want to create my own slice? Right, I don't want that numbers to be there, like I don't want to be creating an array from a separate array, creating a slice from an arrays. So for that I can do, let's do a numbers equals to empty bracket, let's keep it as int, and we provide with the value of 5 10 and 20. Let's do that, and if we do fmt dot println and we save it as a number, let's see, we are not getting any error since we have not provided the size. So if you're not providing a size, that means it's an slice. Go run main.go, and we get 2 3 4 and 5 10 and 20. There is one more way where you can create a slice. You can create a slice using a make function. A make function is a way that it creates is a function that will create a slice and initialize those values to the uninitialized variable. That could be like a 0 for integers, for bool it could be false, and for strings it's gonna be an empty string. So let's just do then slice equals to make, and make is gonna take two arguments. First is the type, which is we are going with the int. Second is the size, we are going with 3. Now let's just print it, and we get 9 slice. Let's see why I'm getting some error. Oh yeah, it's we have to provide with the semicolon. We are not doing one at a time. Let's go, and yeah, so we see that now we have 0 0 0. So there are few key differences. First is that to create a slice we can directly use the array as a reference to create it. Second is that we can also create it without providing it with this size. And third is using the make keyword, which will initialize this slice to the 0. Now, to modifying a slice, it's similar to what we have here. But also remember, doing this will affect the underlying array. So, for in this case, if I go like a slice of 2 equals to 100, and I do a println, which is fmt dot println, I do slice again, and let me just comment this out, and let's run clear, and uh, okay, I'm printing slice again. So let's do a print a slice, and we'll also print right below that to see the differences. If I do this, we see that we have only changed value of slice 2, but it changed value of slide of an array. So it happens because when we are creating a slice out of an index, it's an reference based, not a style value, not a type value like we had with the air, but this is reference value. So when we do that, we are going effectively taking the reference and then we are updating with it. To other way to modify a slice is similar to what we had with the arrays. Now we can also append values to the slices. So let's remove this part and we'll just add this. To append, we use append method. So to use append, we also need to, let's do with append and let's add number. This is where we're going to append. We are going to add the values that we are going to append and save. Here we are getting an error that is value of type int is not used, xyz is because this append is going to return a slice again. So we have to save that into a slice. So we go number equals to append and then we do fmt dot println and we put it as a number. Let's save this and let's run. So now we have 5, 10, 20, and then 5, 10, 24, 5, and 6, which we added using the append method. Now we can also copy a slice. So you remember that the first time when we did that, it created an reference, and using that, it will change the value itself. But there is a way where you can copy a slice from slice A to slice B. So let's put that in action and let's just give it a go. So we are having a number. Let's do num copied equals to, we need to do is make. We have to initialize those value, right? So we go with make and we provide with the empty int type and then with the size, which is length of original, which is gonna be a number. Now the num copied, it also needs to be stored here. Now to copy, we go with the function which is copy. It will take the target and source. So target is gonna be a num copied and source is gonna be number. And then if I do let's say num copied of 2 equals to 100, let's print both fmt dot println number and then fmt dot println num copied. If we take a look now, so this time we have two separate slices not using the same references. So copy will create an independent of duplicate slices without hammering or without working with the reference, so that you will have an independent slice that will not affect the underlying sliced. So the question comes down, when you want to use a slice or an array, the very simple answer is always use slices, because there's no harm. If it's not going to grow, obviously the Go is not going to use any more extra memory. Second, it works exactly the same. Unless and until you know that what will be the size of an array, you can just do anything with slices, and that is used widely. Let's talk about maps. Map is a built-in Go data structures allowing the storage of key value pair. It has the fastest lookup time. It has O to O of 1 complexity and commonly used for indexing, caching, and storing configuration. So let's start by creating or declaring a map. To declare a map or create a map, we can use make method, which we remember from the arrays and slices. Use make, we use make and we provide with the type of a map, which is map, the key of type string and the value of type int. Remember, the type of the map, the type of the key is always gonna be a string. We can use int, but I'm sure it's gonna throw an error if we do int. No, it doesn't. But be sure to use string for better readability and easy access. We can also use string or map literals. For that we can use, let's create a scores variable and we add map we type string, value integer, and to create a map we use curly brackets. So it's a JSON type key value pair, or you can be like JavaScript type object with key value, and we go with value. uh, and then let's create one more. Let's go with Bob and name him, give him score of 30. Or we can just create an empty map which is just using, again, just the map type. We give map type string of value type of int, but we have to provide that curly bracket saying that it's gonna be an empty map. Let's print and see what we get as fmt dot println. Let's print person, fmt dot println scores, and let's we print fmt dot println is empty map. Let's check the value, and yes, we get first is map which is empty. It's gonna be an empty because the make sets it as an empty and we don't have anything inside of it. But because we used map, it has already allocated and initialized the objects that we gonna use later. And then we have scores. Here it uses this particular way to store the data, as we can see here in the output, and this is the empty way. Now we can also add, retrieve, and delete the value. So we are not going to change anything here, but we'll just update a few of the things. First, for let's say for a person, let's add their ages. To add their ages, we can be go like person brackets, and we provided them with the key. Since string is a type, we can go with, let's name it as a Bob and give him an age of 29. Let's add one more person with let's name her, let's use Alice, and provide her with the age of 25. Let's save and just run this. We are not going to do anything else. Yeah. So you can see we can add values using this quotes, or this particular way that we are used to doing it in arrays and slices. To retrieve a value, we can simply do, let's say, an age equals to not equals to, colon equals to person of, let's go with Bob, and again it's gonna be, it needs to be in this, and then post this. Let's print dot println, and we provide with age. Let's save and run. We get 29. But here's the catch: what if this age or this person does not exist in this particular map? What are we gonna do that? So the good thing is that the GoLang also provides something with error, or sorry, exists. So when you run this particular fetch operation, which is the person Bob, at the same time it returns two value. First is the value that is there, and second, does it exist or not. If it doesn't exist, we can just go like if not exists. Sorry, by the way, we don't use parenthesis here. We can just use that. If it doesn't exist, we can be like print dot println, and let's say, hmm, yeah, we can actually do, rather than doing negative, we can do positive println, and we can be like Bob's age and age. Usually this is the preferred and more idiomatic goes way of doing it. So if there's an error and you want to break that program right away, you check if there's an error and you just break it right away. But in the same way, it's like that, like if it exists and you want to use that value, make sure it exists and use the value right away. Do not leave it for later time. Like you cannot do not exist, and basically you can do that, but you don't have to do not exist and then you print like, oh, Bob's age doesn't exist on that. But there is a call for that particular value. Like we were calling this age at line 23 before, that will create or throw an error. And let's say, and also we can delete, obviously we can delete. So to delete, we use delete method of function with the map that you want to delete, and second with the key which is Bob. And I think that should do. Let's print person once again after deleting it. save and let's go. So we have removed Bob successfully. We only have slice. We only have array Alice in 25 in this particular map. Before we move forward, we let's talk about one last thing, which is iterating over and map. To iterate over a map, we have already seen in array we can use something called range. So the similar thing is available for maps itself. So we can do for, let's go with key comma value and assign it to range of scores. And in this we can do fmt dot print format name. We can do like I think percentage s for string, and then we do with age, which is percentage d. Then we also add slash n, so it prints on the next line, and then we provide with the value, which is key comma value, and that's it. Let's run this. Before we run, let's clear our console and then we run this. So you can see we can iterate over and map using the same range operator that we already had. Now let's talk about pointers. Pointers store memory addresses instead of the values. The pointer also helps us to optimize the memory usage and prevent unnecessary copying of a data, which is very crucial when you're working with a very large data set, whether it could be something like a slices or an arrays. So let's start by declaring a pointer to declare. But before that, let's just take a look at what a pointer is exactly. Let's say I have a num and I provide value of 10. Now let's create a pointer to the variable of num. To do that, let's have it a ptr, just a standard name for most of the pointers, and we provide with the ampersand. The ampersand is also known as address of operator. That means it returns the address of that particular variable which is provided after that. So here it will return us the pointer. Right now let's just print and see what's the memory address of that particular pointer. So we do print ln, and let's first print num. Next we'll print three things. Let's print num, let's print and num, or we can just keep it as a ptr pointer, or and the end we do star ptr. Now star here in this ptr, it stands for dereference, is known as dereferencing operator. So basically it is used to get the value or update the value at this particular location. Let's save it, and let me just clear the old console and run this, and we get 10, and we get something like 0xc888810c098. Sorry, not 8 zeros, but this is the memory location, a physical memory location for this particular variable num where this value 10 is stored. Now we can also use star ptr equals to 20, and this will update the value of num. So we will print ln num. We will not print ptr now, we'll just do num. Sorry. So by doing this, what it has done efficiently is that the num which is stored somewhere, right? We went there and we said, oh, sorry, this location is it, but I don't want to do anything here. I want to have this new value at this place. But without using the name of the variable, we just use a pointer to update that. This is very helpful when you're working with something like an functions. Let's take a quick look at function as well. So mostly when you're working with pointers, you are also working with a function. Rather than passing a whole variable, you can pass the reference to that particular variable. This way Go will not create a new value. That means you are saving on much more memory space. Let's create a function first, func, and let's name it as update, sorry, update val, and val, it will take num of type int, and here it will just do like return num, which is the num or something like it was just written num plus 10. Oh yeah, sorry, I forgot to add this type. It's going to return a int, which is something I forgot. And now we can do like, let's call it as a num and provide value of 10. And then we have num equals to update val num. Let's print num now. Print dot println num. This will eventually do the same thing that we wanted. It will update the value and store it in the num. But here's what's happening. As soon as you put num inside this update val, which is here, it's gonna have a new reference, a new value that is being passed here, because it doesn't know where this num or the value is stored. So it will pass the new value. That means that you're using essentially two locations for the same value that you want to update and let it go. That's fine. But if you're working with something like a slices, it's gonna be a headache. So the best way that you can do is, we don't even need to do this. We can just pass the pointer reference using and num. To do that, we can just add star here, and we can do star num plus 10. So star int, basically it means that we are expecting and reference of this particular variable, whatever is going to come in, and it's going to return an int. And if we take a look now, it's same. Why isn't it same? Yeah, okay, yes, I used return, but it should be star num, and it's not gonna return anything. Initially we were returning that value, so there was no change and we were not storing at it, but now it should work. There you go. So now we have 20 without creating a new variable, and this particular update function has just worked with it. I will create a separate video only on pointers in Go, which are much more in-depth detail about the pointers. But just to give you a gist of it, this is how a pointer works. Pointers allows a direct modification of a variable across the functions. Let's talk about structs. Go doesn't have classes. It's not a object-oriented programming language, but Go does provides a way for you to write a flexible and modular code. One of the way is declaring a data models using structs. Structs is a way that will help you to define a complex data model similar to objects in OOPS. A struct is a collection of related fields. Let's understand more about it by creating a struct first. To create a struct, we use type, then the followed by the name of it. Let's name this as a product, and then its type, which is gonna be a struct. So basically, a type product of a struct, or you can say type product is a struct. You can say however you want, but it's that how you can say. Now we need two things in this particular struct. Let's go with name. We can provide it with a string, and then we can also need a price, so we go with price, and it's gonna be of type int. Notice, if you are using any other languages like let's say a Java TypeScript, you might have been using comma, especially for interfaces, but struct doesn't need that. You can just have it on the next line. The line break acts as a set or a cutoff, and it will work as it is. Now, so we have declared a struct. Also, one thing which I might have not mentioned it before, when you are providing a name of any variable, let's say if it's a capital name, let's say if it's a P, small p, capital P, that means it's public. That means anything outside of the package can access this particular struct. But if it's a small case, then this struct is not accessible outside of this package main. So for now, we'll just keep it product. And in main, let's create a product. Let's name this as laptop. We can now laptop, and we add a product since we are using the struct, and then we go with curly brackets, and here we just provide it with the name, and it's gonna be, let's say, Alienware. Yes, I wanted an Alienware. Yes, I wanted that. And let's go with price, and let's name it as a put it as a $1,200. That should be fine. And now we can print this. Print ln, or we can just go with print f. Let's go with print ln for now. So this here is how you declare, how you create a struct value or an object in, if you are from say any other language. Most language has keyword like new, and then you have this, and then you provide it inside of the parenthesis. That's how in most of the languages you do that. But you don't need parenthesis. You can skip the brackets, remove the keyword new, and there you have it. And if you wanted to do like a specific, you can still go with var laptop of type product, and then the product. That's also fine, but I'll just use the shorthand operator, which is very similar. And to access the values, we can use laptop dot name, and we go with laptop dot price. So dot operator can be used to access the particular value itself. Let's save, and here the old one. So go run main. We get Alienware at $1,200. Now there are few more things we need to understand is that the struct can also have a method attached to it, like how we have in JavaScript using prototype or something like that. To do that, we can use function. We create a function, but rather than giving the name of function, we provide it with the struct of that struct for which we want this function to be added. So we go with p, which is the name of this product, and we'll be using the reference, the pointer of this product, which is star product. And then we provide it with the name of a function. Let's call it as apply discount, and we intake discount, which is of type float 64. And we are not returning anything because we are using the struct, and we want this value, whatever happens here, to be inside of this struct itself. It should not be outside of it. So basically we are making an way so that we can change the value of object variables. Yeah, object variables or something, I don't, it's fine. So we do p dot price equals to, we just do equals to minus equals to and discount, and we are converting it to int. That's fine. Let's just do it as int. We don't need to convert it explicitly. I think that should be fine. And now to update that, we can just do like p dot hmm, p product discount. Let's save. Yes, let's do laptop dot apply discount, and let's provide it with the 10%, 10 or $100 discount. Oh no, I'm generous, I'm gonna take $1,000 discount. And now we can do fmt dot println. Now let's print again laptop dot name and dot price. Save. Let's go clear and go run main. Now you can see that we have successfully attached a function, which is an apply discount, to this struct of what we call a product. We just spoke about structs. We found a way to model a data, but we also need a way so that we can make sure that every type or every structure has a similar or the same behavior. It is something that we want to make sure that a particular types can have the same implementation across the board. So interfaces comes here. Interfaces helps us define a signature of a method that every structure or every struct needs to implement. To define a interface, we can use again the type name. Let's go with the speaker of type of is interface. Let's go with type speaker is interface or type speaker of interface. Anyhow, we can just go with just to make sure that we understand. And it only has have one method. Let's name it as a speak and string. Second, we define a struct. Sorry, we have to use type dog struct, and it has name, and let's take it of type string. Now since we have a speaker and struct, now we need to implement the speak method for our dog. So to do that, we can use func, and in bracket we use d and dog. Here we are not providing with the pointer, but we are using the struct itself, because we don't want to work with the values, but we want to work with the type. Yep. So we go with speak of type string, and it will just return woof. Now to call this, right, we do like var d equals to dog of type name, and we'll put it as a name as Tom, right? But we need it to be of type speak. It needs to be of that interface. So we go with s, and we provide with the speaker. This way we are telling that our GoLang that, see, this is the s variable. This variable wants to be of type speaker, which is an interface. So make sure that this dog has the implementation for this particular interface, so that is speak. Let's, if I just do this, we get an error saying that the speaker value is variable declaration, dog does not implement the speaker, missing method speak. Now we can just call our speak method from here, which is using fmt dot print ln s dot speak. Save, and if I do go run main.go and get poof. Now here's the catch. Here's one thing that we need to understand. That is, when I'm setting this interface or speak, I'm losing out on the values of this struct values, right? I can't do this, like I can't do s dot name. But here's the catch. What I can do is I can have like get name, a getter method, which is a string, and then we add one more, which is a getter method, which is gonna be of get name, is gonna return string, and here we will return d dot name. Save, and if we do now like s dot get name, and we should be good to go. So here what happened is that we wanted the value of this, and interface needs to know what is this particular value, or this particular object is gonna return back to me. The reason being that is, when you create a interface, it will only and only expose method, it will not expose the variables in them, the fields in them. So we have to be a little bit more a different way to work with this is this. I think this is very common with the languages like Java or any other object oriented programming language, where they don't allow you an access to the fields without using of a function, which we call a getter or a setter function. Now let's also understand how can interface be used to make a polymorphism work. Like, we need to understand if I can have a same behavior for multiple structs. Okay, so let's go with type animal, and we put it as a interface again, because I don't know why this is really wrong. It should have been just interface animal or struct animal, but no. GoLang wanted this to be type, and then you should provide it as a type again. Okay, and it will has a one method which is make sound, and it should return a string. Now let's implement dog, have a dog struct again, and this time it will not have anything. Let's also have a type of cat. It's a struct. Again, it will not also have anything. At the same time, let's also implement the animal make sound for these both. So to do that, we can use func again. Very simple. Let's do the dog and make sound of type returnable string, and should return, and let's call it as woof. Let's copy this and paste it here, and rather than doing dog, let's do with cat, and it's cat, and that's that. Now here's one thing, that why did we do that, like what's the even use of this? So the reason we do it sometime like this is that we can initialize the interface for the multiple struct in a single line or a single go. So I can be like, I can do animals is of type array of type animal, which is the our interface, and we can provide here dog struct and cat struct, and this should be done. And now I can use like for, rather than using I, let's go with I comma a, which is our array value, and I can just go with range of animals. And here I can just do fmt dot println, which is a dot make sound. If I save this, it's same. Woof woof. Why? Because I copied this. It should be meow. Let's go. Yeah. So here we created a single interface, but we make sure that both of the or the structs has implemented that. So basically, it is the parent element who has the make sound method, and it wants the dog and cat to implement the same thing. This way, Go allows us to use polymorphism of concept of the OOPS language in GoLang. All right, now let's get started on building a in-memory database similar to Redis, but only catch would be that it will not be in the client server model. It will be just a implementation of the in storage so that we can understand how can Go be used to build such kind of apps with very simplicity. So let's get started. So first thing we'll need is an set of functions that we are going to be implementing. To begin that, let's start by creating a interface. So we create a store interface. It will have three functions: set, get, and delete. The set function will take a key and value, which would be key type string, and value would be of type string. We don't need comma. Second, we'll need a get that will again take key string, and last would be delete. That would be again key type of string. We have interface ready. Now we need to have a data store. So for that, let's start by creating in-memory store of type struct, and it will have, or it will just store a data which will be of type map of string and string. So we go like data of map key string and value string. Sorry, uh, string. Yeah. Now we'll also need to initialize our store. So let's create a function for that. Func new in memory store. It will take, and here's something that this function will initialize our in memory store, and it will return us the reference of that particular store. Reason for that is that we don't want our Go to create multiple replica of that particular store or data. We need to manipulate this exact same data which is already available. So for that, we'll return new in memory store of struct, and it will be very very simple. We'll be having return of type ampersand, like the pointer reference to the in memory store that will have data, and we'll use make so that we can initialize it with the default values, and it's always available for us to use. So let's save this. Now it's time for us to start implementing the store functions. To start with that, let's start with set. uh, well, let's start with set. So we again, as it will be an interface, not interface, but would be a struct. So we go in memory store, and it will be set. It will take value key of type string and value of type string. It will not return anything because we have already got our in memory store pointer, so we don't have to do return any new features. So any new part that can be stored somewhere else while we are just working with the single store. So it would be s dot data, and then the value would be key equals to value, and that's it. That's all we need. Now let's implement a get function. for that, we again do s start in memory store. We put get of key type string, and it will return a pointer to a string because we are not returning a data from our usage. We're returning a data that is already in a store that can be later be used to change some stuff. So let's go with pointer to a string. And here, first thing that is we have to check if the value exists or not. So its value exists, and then equal to s dot data key exists. Yes. Now here's the thing. We are setting value and exist at the same time. And if it does exist, then what should we do? We should just return ampersand to that value. And if not, then we just return nil. And that's it. It's that simple. So nil is equal to null. If you have been some other language, you know you must have heard null, but this is different. And last function that we are gonna implement is delete. So it's again as taking in memory store, and it will not return anything. So it will just take key of type string and not gonna return anything. So we just go there and we just run delete function as dot data of key, and as dot data, sorry, we have to provide key as a separate value. And that's it. We are done with the implementation of our store. Now we just need to create a store and add this stuff. So let's go with let's create a store first. Store is gonna be our new in memory store. Next we set store dot set. We'll set a value, let's say name, and we'll set it to GoLang. The first key set. Second, let's check for value equals to um, store dot get, and we'll just check for name. Again, one thing we have to fix is that it should be small, and since keys we should always use small letters, not the capital ones. Now if value, again we don't need this parenthesis, if value not equals to nil, at the time we will do fmt dot did I get fmt? Yes, fmt is imported. Fmt dot println, and we'll just say retrieved, and then we'll add value, or else we'll just add fmt dot println, and we'll say key not found. And the last thing that we'll need is to just delete it from our store. So s dot delete, and we'll delete let's say name. We don't want anything extra here, so we can just delete the name. And last is now we just check again to get store dot get, and this time we'll again try to get name. And now we know that this time the value will be nil, so we will just copy and paste this block here. And yeah, that's it. Let's try running this program. Right, go mod, not mod, go run main.go, and waiting. We got that we have received the location of this, not the value itself, but I think we are getting to the some point. So we got key. Let's take a look at what we have. Key, yes, so we are receiving a reference, so we'll just use star for both sides. We got retrieved as a GoLang, and then we got key. And congratulations that you have just written a very simple Redis store that you can expand on. Maybe if you have seen my last video where we had written calculator, you can use some of the logic from there to build this particular Redis app, which will always be running, and you can keep on working with it for a longer period of time. And for me, I would say thank you very much for being on this journey for this video, and happy coding.